Hello. Thanks for joining. Sorry for the delay. That was completely my computer having Monday's issues. And actually, if anyone notices, I'm on my phone. So this is gonna be super exciting. But we have to show you EKS Anywhere. It was a must. So wonderful to have Sheetal back with us. Hi, Sheetal. Thanks for coming.
Hello. Yeah, I'm excited. We have Vivek here, who has been working on EKSA for a long time. We couldn't think of any other better person to have and come share space with us here to tell you all about EKSA.
Yeah, I see I'm still having some problem with streams here, but I'm gonna figure that out. So if anyone hasn't been paying attention last week, oh good. It looks like I was gone for a second and then it looks like I'm back. Oh, and I can't. I can't pop in comments. This is an unfortunate. No, there it is. Okay. Never mind. I'm just trying to get used to. I have it open in 2 places. This is hard sometimes. But you know what else is hard? Kubernetes on-prem. So my transition right there. If you weren't paying attention last week, we officially GA'd EKS Anywhere, which was pre-announced at reInvent last year for running Kubernetes clusters on-prem. It takes a lot of the EKS abilities of how to manage life cycles of clusters, really all the best practices that we at Amazon have learned for years and years running Kubernetes at scale and helping you do that on-prem. And like she said, Vivek is here to help explain a lot of that and go through. We're going to show a demo of it, obviously. Vivek has been one of the core engineers building EKS Anywhere, and I'm super excited just to have everyone see it. Vivek, why don't you give us a quick intro, how long you've been at AWS and what specifically, like, was there a focus that you had on the project?
Yeah, thanks for having me here. I was at AWS, I guess I'm at AWS for like a total of 3.5 years or a little over that. So I've been here for a while. I wasn't on the Kubernetes team most of the time. I was on a different team and then I transitioned into here because I really wanted to get into the nitty-gritty of containers and how AWS operates containers at scale. And what other better place to do it than EKS? So I came across this specific opportunity to work on EKS Anywhere to bring our Kubernetes platform to on-prem. And over the last basically half year, we were working on this EKS Anywhere product, really thinking about the end-to-end on what the user experience is going to be like. And since our main tool to do it is through our CLI, that was the effort that I was helping lead to essentially bring that end user experience as seamless as possible so that you could just, create clusters, upgrade with single commands. And that's what I'm excited to demo in a bit.
Awesome. Pull this out of the way. I wanted to, if anyone didn't know, we did open source it. So here's the landing page for EKS Anywhere. We have, part of this open source project was a lot of just letting people see the project and see the code and run it themselves. And one of the things I'm most excited about when we announced it and we're working on it was the fact that it is fully open source. So it's here on GitHub /AWS/EKS Anywhere. It works on using a lot of existing Kubernetes projects, and we working in the community to really refine a lot of those with how we wanted them to work for customers on-prem. And so to me, the coolest thing is just like, you don't have to be an AWS customer. You don't have to have an AWS account. There's no connection requirement back to AWS to try it out, to use it, to run it. Go ahead and do that. It is fully supported by AWS. If you want the support, you can pay for support. You can get a transition from, hey, I have a production cluster. Now I need someone to actually, help me out with this. And that's one of the benefits here of like, give it a shot. If it works for you, awesome. Use it how we're like plugging in things and expanding it. We're listening to everyone in open source on what they need. But then from there, we're just running with, here's the open source, but here's how, if you wanted to integrate better with AWS, we have the EKS connector. We have, other authentic, like OIDC is there right now, how we work with providers, all that stuff is coming. So I'm really excited about it. I'm also realizing it's really hard for me to mute my microphone when I'm here on my phone. And I don't know if anyone else is seeing screen flashing. I'm going to stop my screen share because it looks like I'm flashing. We are having some weird stream problems. I saw other people in the comments mention it. So, and because we were a little late too, let's actually just dive into a demo here. And if you had a chance to look at documentation or give EKS Anywhere a spin, let us know, because we want to hear your feedback and what you were working on and what you're trying to do with it. But I also know Vivek has already prepared a couple things for a demo so that we can look at it and really see some of the benefits here for running it.
Yeah, definitely.
Let me pull in your screen.
Okay.
So
yeah,
tell us what you have.
Yeah, so I have a blank terminal right now, but I'm kind of going to walk through how the tool is going to work for EKS Anywhere. I have actually created a cluster before to save us time with like showing that whole process, but I will be demonstrating the upgrade workflow as well as how you can change some fields through Flux if you have your code in a GitHub repository as well. So I have this terminal here. I have EKS Cuddle installed already. And if you're familiar with using EKS Cuddle for bootstrapping, EKS clusters, you notice some of these commands already. But this new command that we added over here is EKS Cuddle Anywhere. We have a separate command for EKS Cuddle Anywhere just to help bootstrap the resources specifically to EKS Anywhere, as all the other commands, they're already built from the EKS perspective. So we thought, like, as we're introducing EKS Anywhere, it would be easier to introduce it this way. And if we were to type EKS Cuddle Anywhere, you can see that we have a couple of commands listed over here for being able to create, delete, and generate like the cluster resources. So right now we mainly support creating just a EKS cluster that's a managed cluster, and you would also be able to upgrade your cluster. So like the main core operations you do here is create, delete, and upgrade. And we have a generate command here just to make it easier for you to be able to understand what fields you need to configure. For example, if I do something like test -p, and the provider that we're mainly working with is vSphere for your on-prem use case. You can see how this command basically outputs a bunch of configuration for you, where you can kind of modify, for example, what endpoint do you want your control plane to use? What's the count of your external etcd configuration, your control plane configuration, and some of the other fields that you would want to specify for vCenter. So one thing you'll notice here is that we have external etcd configuration support. And this is because that's how we operate etcd for EKS customers itself. From an EKS perspective, we give you the control plane. So we handle that management for you. But from an on-prem perspective, we're letting you basically have all those pieces in one location so that it works for you for an on-prem, but in the same way that we set up EKS on the cloud.
And if people are used to EKS control, if you're creating an AWS hosted cluster, there is a spec file that you can use that you can say, hey, I want to create a cluster in AWS. how does that, there's a YAML file with like what type of node groups and that sort of stuff that you need. And this is a very similar model where that pushes that configuration into CloudFormation, which does that sort of reconciling of state to say, okay, this is what we need. And in this case, this is, we have a slightly different spec because it's completely different environments and different tunables of what you can actually do on-prem. But the workflow is similar, right? We create a spec and then we run the command to actually do something.
Exactly, that's exactly right. And I actually have a spec of the cluster that I have created already, where I have some values defined, like I have GitOps configured. I have some other like information on the machine config, like the number of CPUs I want, memory MIB. So if you're used to like configuring these type of resources for EKS, you'll see that maybe some of the field names are a little different here, but like for the most part, it's a similar experience of taking a YAML and making resources like available to you. And one major difference that we're doing here is like you're talking about from an open source perspective, that because we're open source and we're trying to leverage what is available to us from an open source perspective, we actually do rely on Cluster API, which is a Kubernetes SIGs project, to be able to create these resources for us. So like instead of relying on something like CloudFormation, we are creating these resources using Kubernetes, which I can kind of show that workflow as we're doing like the upgrade workflow as well.
Hey Vivek, we have a question.
Yeah.
Is it only vCenter or do we support it on ARM or any small factor devices?
So we started off only supporting vCenter because that's kind of the major use case that we had for EKS Anywhere. We are going to have other providers support as they come. And this is where we want to leverage our open source contributions and like issues as much as possible. If there's a request that you have, you could just go to our GitHub page, and we have a lot of issues. I think someone has already asked for like Raspberry Pi and some other stuff. So like we have a lot of asks that are coming in. We can only address certain ones based on like the interests that each have, right? So that's how we're kind of working towards like support for certain things. So definitely like +1 on issues, create issues on GitHub if you definitely have some of those requests. But yes, we are starting off with vSphere as support. Yeah, I see another question there too. OS family is Ubuntu. So we actually support both Ubuntu and BottleRocket. And if you're running the generate cluster config command over here, you see how it generates BottleRocket by default. Just for demo purposes, I didn't actually think about this too much, to be honest. I just set it as Ubuntu. So then that's why we have an Ubuntu cluster. But if I had set it as BottleRocket, then we would have a BottleRocket cluster. So it's as seamless as that. Like you would be able to try this with OS family BottleRocket, and it would set it up using BottleRocket.
So would we flip that switch and make BottleRocket as default, or do we just keep it an optional for users to specify?
Yeah, so that field is something that you need to specify. So when they run the generate cluster config and when we're generating default values, we do default it to BottleRocket. But if users want to use Ubuntu, they have to change it to Ubuntu. So for the demo purposes, I just had Ubuntu. Like there's no other reason for it. It just shows that you can do it with both OS families.
And for anyone that doesn't know, BottleRocket is an AWS open source operating system for running containers. We've had a couple containers from the couch episodes on it in the past, but it's not something that everyone necessarily knows. So I'm just pointing that out as well, that this, BottleRocket being an open source OS by AWS, again, it's fully supported by Amazon if you need that support. And it's also very secure because it strips out a lot of things that you typically wouldn't need on a traditional Linux operating system. It's API driven. So go check out the containers from the couch I did last year for BottleRocket if you want to learn a little more.
Yep, exactly. And here I actually I ran the create cluster command to kind of show like the options that it had. And our main way to basically create a cluster is based on that file that we generate. We specify that as the file name to be able to create your cluster. So that's kind of how we take the input for the create cluster command. So for the interest of time in terms of like the demo, I've already ran this command. And if I go to this other terminal window that I have, when I run kubectl get nodes, you can actually see that I've configured a Kubernetes cluster with 1.20, and it's running our latest EKS distro version for 120. So EKS distro is something that we had actually launched end of last year as well, which is our open source distribution that aligns very well with what EKS is using for their distribution. So it's like, if you just specify 120, you will know that you will get whatever is the latest EKS distro version that's 120.
Right, this is all layers, right? This is like at the very bottom here, we have Bottle Rocket as an OS that Amazon open sourced, a couple of years ago. On top of that, we actually have the API, the binaries from Kubernetes, which is EKS distro, which is what we run in EKS hosted in AWS. So you're getting the same containers, you're getting the same bits with, if you read the repo, backported patches and some fixes and those sorts of things that we needed inside of our environments. And so EKS Anywhere is just building all these open source tools to package that all together to make it something that we think is good for customers trying to run on-prem. And I saw this question come before about this being a wrapper around Cluster API. And if you're familiar with Cluster API, yeah, exactly. There's a lot of pieces here that this is using Cluster API, the core pieces of Cluster API for a controller and for the spec and CRDs. And it takes a provisioner and ties those things together. So in this case with EKS Anywhere, we're more productizing some of that open source bits to say like, hey, that's actually a lot of decisions you have to make. And there's a lot of choices around, hey, how do I want to implement this piece? What CNI do I want? What integrations do I need? And in this case, we're taking, we take that best in breed tool and saying like, this is how you can manage Kubernetes clusters at scale. Let's help customers make some of those decisions and make it a little easier to deploy and use. Because the first time I ran Cluster API, I was very confused. There was a lot of controllers. There was multiple CLI tools. There's a lot of components in it that just, I was like, okay, I could understand this. I could probably, I built clusters with it. But then ongoing maintenance and support became difficult because of all those divergent, integrations and things that were, for me as an operator, were a problem. And EKS Anywhere, we're trying to help you make some of those decisions and options. We can add those things, but we tried to stick with what we saw as a lot of people using and what we saw first, just stability and support reasons. We wanted to allow people to do easier.
Exactly. And we have a lot of, we basically made a lot of opinionated decisions here to be able to provide some of that functionality. And one of our main, like from a user experience perspective, like motivations is, how can we do this all in one command? We should be able to create a cluster using one command. You shouldn't have to run like 10 different commands to be able to create your cluster. Now with 10 different commands, you can get more customizability, but that's not how we were focused, right? So
yeah, the flexibility is great. Cluster API, you can start with the base controllers and go anywhere and do anything you can do with normal Kubernetes. That may not always be the best option. So we really try to, in EKS Anywhere, find the path of best supportability and what we see a lot of people wanting to do. And one other question I saw come in about can you deploy it to pre-provisioned nodes? Let's say I have a rack of servers, they have an OS on them. Can I point at those IP addresses or those MAC addresses and do that?
No, we don't have that support right now. When we, especially with our vCenter support, we're creating new VMs. We're bootstrapping those VMs and setting them up. And that type of support might be in the future. That's not something that we were thinking about from like a GA perspective.
Yeah, but we definitely hear if you want any of these features and providers and support, absolutely open an issue on the GitHub repo. We're looking at those and trying to see what it is that people want next. We know that we need bare metal supports. How that actually gets implemented is a little bit like how we're actually doing that for customers really depends on that initial feedback. So we want people to give it a try and let us know what they're doing.
Yeah. So here, I actually just ran the get pods command, just kind of show what are all the different pods that are running in this Kubernetes cluster. And you can kind of see that, yeah, we have some controllers that are CAPI controllers running there. We also have an EKSA system controller, which is more used for our Flux use case, which I'm going to demonstrate just now. And then we install other stuff like we have an etcd ADM controller there. We have Flux that we've installed for you, which Flux is also a project that allows you to basically enable GitOps. From making a change from like a Git repo, you can synchronize your cluster with those changes essentially. And we can kind of, I'll show basically how you can do that with cluster management itself. And yeah, some of these other ones are just self-explanatory, like kube system stuff. So here with this, I've actually created 2 clusters. The one that I'm going to demonstrate is this first one that we're showing the pods for. So we can see here for this demo that we have these folders, and under the EKSA system folder, we have this YAML file. And this is the YAML file that we basically used to create the cluster. We went ahead and uploaded it to the GitHub repository in this case. Right now, the only provider we support for GitOps is GitHub, but other providers would come as there is interest for it, right? So if you have other use cases like, oh, I wish this is in like Bitbucket or like some other providers, like that's where we would be able to get that information from the GitHub issues if you're able to add them there.
Yeah, and there is a question on, I think, what CNI is being used. I think Justin mentioned that's a Cilium because it's not AWS in region, so it's going to be Cilium. I don't think experience differs a lot there, but yeah, it's Cilium for now.
Yeah. Also, I think the question was phrasing it as like what's provided for EKS distro. We don't actually package a CNI for distro. We package it through Anywhere. So that's a clear distinction. Like if you were to just download EKS distro and just install your Kubernetes cluster, you would still have to make a decision on what CNI you need. It's with this opinionated tool that like we decided with Cilium. So here you can see like, okay, I have a count of 3 for external etcd configuration, control plane.
Can you pinch to zoom that a little bit?
Yeah. Oh yeah, pinch. That's easier.
There you go.
So you can see some of these other values that we have, like 120, like everything that I basically like showed earlier, right? So I want to make a change from this Git repo where I want to just scale up our worker nodes. And I just want to make that as a code change. I don't want to get into the Kubernetes cluster and make that change, right? So let's just make that change real quick here. So if I edit this file, I go ahead and change this 2 to a 3. And I'm just going to emulate creating a PR. So if a user, someone like an administrator, someone is like, making this change, you can get this approved and view this change. And as you can see, all I'm making is a 3. So for the purpose of this demo, I'm just going to merge it so that you can see that this Kubernetes cluster is synchronized, like this configuration is being synchronized to the Kubernetes cluster. In the meantime, I also wanted to show the upgrade use case, right? So from the created cluster, we actually create this folder with the name of the cluster that you created. And here you can see how this is going to be changed to 3. So I'm going to change this to 3 for the upgrade use case. And for the upgrade, I want to upgrade to 121. So let me change that to 121 real quick. That's the only real change that I'm making. Here we have some templates defined too. So I'm going to remove this template field because I'll show how it works with not having a template defined. So the only change that's really being made is this 120 to 121 when I'm doing the upgrade case. So now by this point,
real quick,
the Git repository would have already synchronized the Kubernetes cluster, right?
And that's what actually I wanted to take a pause on that and just see. So you have 2 things in flight right now. You have the 1 PR from GitHub, and because you're using GitOps inside the cluster, you have the Flux controller running. that looks at the repo for changes. And so this is slightly different if anyone's used to a traditional CI/CD where my GitHub, Jenkins pulls that in or something and then pushes out a config out to some endpoints. And so a lot of people are doing it that way. It's a great model to have that sort of infrastructure as code. Let's get things out there. In the GitOps model, we run a controller inside the cluster that does a pull instead of Jenkins doing a push. And so it's a slightly different model if anyone's not familiar with it. And that was one of the things we pointed out earlier, where this Flux configuration for GitOps, I think I put the link somewhere in here. We worked really closely with Weaveworks to be able to enable this and say, hey, we want to have Flux inside the cluster to be able to allow people to do this GitOps model, because it's literally what Kubernetes is doing with controllers, right? You have controller looking at that API and doing a pull-based method. I also saw a mention here of it's Flux v2, and right now at GA, this is Flux v1, so it's not v2 or we something. I forget the name of the new project that is like an overall wrapper for this. And there's also questions about Argo being supported, and not currently. We have Flux v1. We wanted to allow people to start with this model of saying, hey, from a developer, it looks very similar to every CI/CD you've used in the past, where I git commit code and changes happen. But from a security model and from a functionality model, it works slightly different, where we have a controller inside the cluster that doesn't pull. So that was the first change. The second change is actually, we want to upgrade the cluster, and you're just resetting that sort of spec to where you need it to be, or where it was going to be from that, so that you can actually show the entire workflow of, we were on Kubernetes 120, we want to go to 121. We already assume that the free node change has been applied because Flux is just really good at doing that. And we don't really have to question, like, is that going on or not, right?
Exactly. Yeah, no, that's great that you were breaking it down. That's essentially what I was trying to do. I was trying to change that worker nodes to show like the count to 3, because I had already made that change. Because Flux, it was, as you could see from how long it took to come up, it took about like a minute. It took time to be able to see that GitHub repository as it's doing that polling to see like whether it noticed a change, and then actually applying it and talking to the appropriate controllers to then synchronize the changes. So now we can see that, like, when I had described it the first time, it didn't show up, then it's showing up as being provisioned, and then now that node is finally ready. So it was able to scale up to 3 worker nodes.
And I also want to take a little bit of a tangent here to talk about Delboy GG asked if there's anything EKS Anywhere is doing for throughput bandwidth if you're using a direct connect on-prem. And the answer is actually no. In this case, EKS Anywhere is giving you Kubernetes on-prem. So there's nothing specific about EKS Anywhere that's like doing some sort of special connection or looking at like your customer account or region or anything like that. In that case, it's direct connect from your data center into AWS if you're accessing AWS resources. Again, a requirement, but something that plenty of people are doing. There is an EKS connector, which allows you to see your cluster from on-prem in the AWS console, but again, it's an optional thing, and that is using a slightly different technology. It's using session manager tunnels, but still, if you're going over direct connects and it's shared, that is all up to your data center, your ISP, and that direct connect. Nothing EKS Anywhere is doing specific for that to manage bandwidth or access.
Yeah, and I guess there are leading questions on how on-prem data being on S3, right? How do we access that? And load balancer controller egress. Maybe Vivek, you'll be covering in the demo, but Justin, I guess we would want to talk about it.
Yeah, I mean, to these points of how that integration works, like the load balancer controller, if you're creating AWS load balancers and you're using it from an on-prem Kubernetes cluster, it's the same things you'd have to do for any on-prem Kubernetes cluster. You need to the load balancer controller running your account needs to have some authentication to the AWS API. It's not necessarily like a pod-based IAM at that point. It is, some sort of authentication, IAM permissions that you are setting up, and then how you're routing that traffic from the load balancer back down is the same as you would do it for any on-prem server and an IP address. So there are other configurations you need for like opening firewall ports or direct connects and that sort of stuff. That is up to you for an on-prem compute environment, which isn't any different with EKS Anywhere versus a standard. If you had a server in your data center and you want it behind an AWS load balancer, you would do all the same steps. And so Vivek, what you ran the upgrade command here?
Yes. So I was just running that in the meantime, just in the interest of time, in case so that we can see the result in the end. But essentially, all I did was I had made those changes to the demo YAML file already, right? Where all I did was I needed to change the Kubernetes version from 120 to 121. So this was the file that I had changed it in. So I just went ahead and specified that file for this upgrade command. And you can use this upgrade command not only to make changes to the Kubernetes version, but also some other changes that you would like to make to your infrastructure. For example, through Flux, we don't support the ability to be able to change the control plane count because that's in order to make changes to that, like in terms of like a control plane or things like that, we need to actually move the management out. And what I mean by that is when we create this EKS cluster, we are actually creating a self-managing cluster for you, meaning all the management controllers that exist, if you instead of having a separate management cluster, all those controllers and stuff would exist in this one cluster, so that you only have to deal with one cluster. You have a single point, like everything's there. Like you won't have like the single point of failure from like a management cluster. And that's kind of initially what we had thought, right, on going forward with. With that, in order to actually perform some of these upgrades, like changing the Kubernetes version or things like that, you can see from this upgrade command that we go ahead and create a Bootstrap cluster. And during the create workflow, we create a Bootstrap cluster, which is a kind cluster essentially, where we install cluster API controllers on it, and we create those VMs and etc. from that Bootstrap cluster, and then move the management over. So that's what we're kind of doing for the upgrade workflow as well, where we're taking that management, moving it back to the Bootstrap cluster, doing the maintenance and upgrade, and then we'll move it back to that workflow cluster. So it's a short-lived cluster, like it won't actually persist after the command. So some of the things that we had to, yeah.
Just say a couple more questions are coming in. Is this similar to ECS Anywhere? And ECS Anywhere is the ECS control plane lives in Amazon, and you create worker nodes that connect back to that. And so you're able to, from AWS APIs with ECS, say, hey, I want these workloads to run on-prem. EKS Anywhere is a different operational model, like Vivek was just saying. Everything is on-prem. You could, well, right now it's not enabled to be able to do a fully offline, air-gapped environments, but we would like to enable that in the future, where there is no requirement for an EKS or an AWS connection or even an account. Everything runs in your data center. It's a control plane that runs locally. When you need to connect to it, you aren't going outside to AWS APIs and routing back in or anything. You're connecting directly to an IP address on your network, and in this case, in a production environment in vSphere. And that also enables us, when you run the local cluster on your local machine, just like Kind, that API server, the control plane, etcd, and the worker node run locally on your laptop. So you don't even need an internet connection if you have the images pulled to be able to run that. So it's a different model than what ECS Anywhere is enabling customers to do by saying, hey, I don't want to be responsible for the control plane. I just have a bunch of nodes that I want to run jobs on. In this case, it's a fully fledged on-prem Kubernetes cluster that is for you to connect to, but also for you to, or you're responsible for in a lot of ways, where there is etcd that should be backed up, and like access to the control plane, all that stuff is in your environment, and you need to secure it and manage it just like you would any other server that needs some sort of level of security.
Yeah, so some of the things that had happened here for the upgrade command, which is similar to what happens for the create cluster, is we have to basically authenticate based on some of the configuration that you have specified, right? So we make sure that we're able to connect to that vCenter environment. We're validating some of these resources that we have. So these are some of, I guess, like pre-flight checks that we do before running create cluster and upgrade cluster commands. What's different for upgrade cluster is we talked about the EKSA controller, cluster controller, right? And you could always have a situation where you're running an upgrade, but maybe someone's making a change to GitHub and like merging it and etc. Right? So that's why we're pausing the reconciliation with the GitOps controller, with or here Flux controller, so that we don't any changes that happen from the GitHub perspective would get paused while we're doing this upgrade. It's like a it's in this maintenance period basically. Like those controllers are being paused and we're applying some other changes when running the upgrade cluster. So this create bootstrap cluster, we create this kind cluster where we install some of these cluster API providers to be able to run some of that maintenance. And this output is pretty self-explanatory here. It's basically moving the cluster management from our workload cluster to that bootstrap cluster. And when we're saying upgrade that workload cluster, we're taking in the changes that you made to that YAML file. We are taking care of what that means in terms of translating it to whatever cluster API understands, and as well as whatever other things that we're doing on top of that, and going ahead and upgrading the cluster on your behalf. So from the user's perspective, the only changes you really need to make are changes to this YAML file and running these commands as a one-time command. There's no other like, oh, you need to, you know, if you had experience with maintain a Kubernetes cluster, like you have to like cordon nodes and like drain and like make sure that you're like handling that maintenance stuff from a very manual process, right? We're doing this all for you in the like a backend, so you don't have to maintain like all that yourself. Like you just have to interface with these commands.
And to your point, also like upgrades, we have to work this way because we want to move that control plane off, make the changes, and then call those v's for APIs. We do also have plans to enable a centralized management cluster. So you can have a management cluster that can enable and control multiple EKS Anywhere clusters. If you're familiar with Cluster API, that is the traditional design that they have. In this case, we wanted to enable both the small sort of one-off, like, hey, we can do a one-to-one self-managed cluster, or the I have hundreds of clusters, can I manage those from a central team or a central place? And that's what the management cluster would do. And in that case, a central management cluster doesn't do this same bootstrap cluster on my local machine to make a change. You would call the APIs in the management cluster, which would then control the other clusters. So there are different ways of operating here, depending on what you need and what scale you're working at. But we want to enable both.
Yeah. So this is what we currently have right now with that bootstrap cluster that's being created on the whatever machine you're working on. But yeah, that we do have plans for that to basically, especially if you have that use case where you really need to manage hundreds of clusters from a single point, then our CLI would be able to interface with that so that we can create and upgrade clusters through that cluster. But yeah, that's currently a work in progress.
You know, it's really hard trying to beat Wally to the answer on some of these questions coming in through chat. He's on top of it. Can you also, I don't know if you have another terminal. I was actually curious to look at the Flux logs for the change on the scale up. I don't know if it shows when it gets that pull in and what it actually does.
Okay, let's take a look to see what we can find there. So I'm gonna export the kubeconfig here. So it's demo. So I'll show the EKSA controller logs real quick first. So EKSA, in this namespace, we have this controller logs. So if we were to do kubectl logs minus n, so this is the controller that we install on the Kubernetes cluster, and basically when Git is making changes, Flux goes ahead and takes those changes from Git and applies it to the Kubernetes cluster, and then our controller takes the reins from there and then makes the appropriate changes to the cluster API objects. So if we do ls here, oh yeah, I need to put a manager. We have a manager. Okay, so now we're in the logs, the nitty gritty like logs basically. You can see, let's see. Where do I'm trying to look for where these logs may come up because right now, like the reconciliation is paused here. And when we moved some of the management back to the Bootstrap cluster, then it's like not able to find some of those resources, but it would essentially get resolved once it does. I'm trying to look for where we did the scale. It should be worker count. One looking up. Yeah, so we don't have like a super clean way of like trying to look up exactly where the count is.
But was the scale done? The scale up was through Flux, or because this controller, there's two pieces in the cluster, right? There's the controller managers from Cluster API that we're also installing to help manage the cluster aspects of it. But then the changes, the actual like Git pull is the Flux controller, correct?
Yeah, the actual Git pull is the Flux controller, which then once it makes the change to our EKSA cluster object, then our EKSA cluster object is actually doing the scale up to like the 3 worker nodes, like we were saying. So that's what I was trying to look for where our controller was doing the scale up. But we can also take a look at the Flux logs as well. So if we do get pods minus n Flux system, so we have all these controllers. Wait, shouldn't there be one? Let's see. Whoa, it just paused. Let's see. Is it not? I'm wondering if it's talking to the right kube config.
I'll pull in this question too.
Yeah.
Whoops, now I lost the tab. We do have a roadmap and issues. Go ahead and check out the GitHub. I'm going to paste that back in here to the chat. So it's a great place if you have things that you're looking for that you want on the projects. If you're looking for new providers, please add an issue there so we can track just in general like feedback. But we are looking at, I think there is a project on the repo now. It's not fully fleshed out because this just launched on, what day was that? Wednesday. But we're still working on adding new things as we're working on them. So for sure, check out GitHub and get involved there if you want to see features and check status of things. And I saw one more. Where'd it go? Oh, Del Boy, GG. I just want to call this out too. Sometimes on-prem static is actually great. If it doesn't need to be dynamic, if you don't have jobs that fluctuate a lot. I know you mentioned you're running ETL jobs for, I think it was geospatial stuff. If you know that scope of those jobs, then I don't personally see any reason it has to be dynamic. I do understand hardware dying. Yeah, that is sometimes a problem when you have to redeploy things because hardware failures. For sure, it is nice for 100% to have things that can, adjust and sort of react to things coming in and out and be more flexible. Dynamic scaling right now, EKS Anywhere doesn't have any sort of auto scaling for nodes. So if you are looking at, hey, when CPU threshold across the cluster reaches some point, I want to add nodes or remove nodes, that's not currently integrated. We definitely have some plans for that. And because this is using cluster API, there are ways to work with the autoscaler and things of that nature to make that work. But right now, we're still trying to figure out how to implement that and make it as easy and simple to implement as possible, because we don't think everyone should have to learn all of the like flags for cluster autoscaler. So there's components there that we're still trying to just make them as simple as possible for people to implement and run and support. And those are the things that are typically really hard when you have 100 different choices, trying to narrow that down to say, I need these three. Maybe you shouldn't have to be an expert on everything in the cloud native ecosystem, but definitely it's nice to have some aspect there of being able to react.
Yeah.
F5, Wreck-It Ralph, what is he doing here? That's awesome. Anyway, F5, yeah, if you're on-prem with F5, we have a guide on how to implement KubeVip, which gives you a virtual IP address for services inside the cluster. You can use that in F5 and just say, F5, here's my endpoint, please route for this. And F5 actually uses its own virtual IPs. In the past, if you're doing things semi-statically, like was pointed out earlier, you can also run an ingress controller as a daemon set and point F5 to all of your node IPs and say, hey, all of my nodes have 443 and 80 running. The F5, you can put in all those IP addresses, or you can even have a controller or something called that F5 API. There's nothing integrated right now for that, but I know F5 also has some pretty cool tooling around Kubernetes to allow it to figure out where services are running. So look at the upstream docs. We're not necessarily building everything into EKS Anywhere. There's a lot of pieces where we've been working with partners just to say, hey, what's your support look like? If you need storage, if you need load balancing, if you need other things, we don't want you to have to throw away all of your on-prem investments. Lean into those with your vendors, talk to anyone that you've been using support from, and keep getting that support. It isn't like you have to now use everything in EKS Anywhere. No, plug in the things that make sense and use the providers and the other tooling that exists in the ecosystem that'll solve your problems.
And all of the existing cluster integrations and what we suggest and what we have worked with and what we have tested. I just pasted a link, cluster integrations for ingress and load balancer.
I'm finding that link. Where did that go?
I just pasted. Sending it again.
I know we're also coming up on time. Did the upgrade work?
Yeah.
So many great questions. I didn't even follow up with it.
Yeah, no, it was just doing its thing, but it moved the cluster management back after it upgraded that workload cluster, and now it says cluster upgraded with a nice emoticon. Now if we do kubectl get nodes, all I had to do was change 120 to 121. So now you can see that it's using the latest available for 121 for EKS distro here. And I actually I didn't get to show like the service running before I ran the upgrade. It totally slipped my mind. But I had this like deployment already where you just curl it, and something that Justin worked on. And all it shows it's hitting the load balancer that I had, which I had installed like KubeVip on here before, after creating the cluster. And we have those docs on the EKS Anywhere docs as well. And it's able to hit the service after doing the upgrade too. So there's no disruption to that service here. But yeah, like that's essentially how upgrade is. I'm like, from a changing Kubernetes perspective, it's just a matter of changing one line and running the command.
Yeah, and that was the workflow we wanted for people. You change the text config, it's declarative infrastructure, and let the actual controllers do all the work. And it's not a human that needs to be in the loop and do those things. So, yeah.
I think quick questions. Add-on support. Any plan to support managed add-ons?
Yes. We would love to. Right now, manage add-ons is mostly core DNS and VPC
Yes.
CNI, and so half of those add-ons you don't need on-prem or you wouldn't necessarily want. So 100% we're working on a lot of things with add-ons to add more functionality, but also to let you figure out which add-ons you want to manage. So we want to make managing a cluster easier because there are a lot of things that have to go into Kubernetes on top of, hey, I have an API server. Now what? And we're trying to make a lot of that just seamless and upgrade with the cluster and be more of this infrastructure as software sort of model of declarative specs that controllers run on. But it does take time to integrate those things together and to make sure that every environment and every add-on that people want, we can support and give the flexibility people need.
So yeah, regarding that, like add-on support will definitely come based on interest again, right? So if there's any specific add-ons that you would like to get added as part of the cluster creation workflow, like please add those GitHub issues. Like that's what's gonna help us tell us like what is it that people want to look for. Like for example, like we are installing Flux controllers and stuff almost like an add-on in a sense, like that type of the GitOps integration gets installed after the core cluster is actually created. So we do have room to be able to support more add-ons in the future as well as part of the workflow. Ideally, we would want everything to be configured through that cluster spec file so that it's like Justin said, declarative configuration, so that everything is just there at the very beginning, and then you just run the create cluster and everything should just show up as expected to you. So yeah.
Thanks everyone for joining. We do need to close out because there's another stream after us. I will say there was a couple questions in here about like logging and monitoring, how to get updates on like what's happening for EKS. Follow here on Containers from the Couch. This is where we talk about most of the new services, new launches, new features. This is a great way to stay informed on AWS and EKS specifically, and then also follow the AWS Containers blog, are kind of the two places that I think most things come in with information. On here on the channel, we really try to show off, you know, what we're working on and intro demos of it. Vivek, you did a great job showing both those use cases of, you know, deploying and upgrading things. So, but yeah, that's my best. Like right now, there's a lot of places to get that news. We really try to focus on EKS containers, AWS here on this channel, and then the containers blog is another great place. So I think, yeah, we need to wrap, but thank you everyone for coming. Feel free to reach out, leave some comments. I know all of us are looking forward to hearing feedback on GitHub and what you're doing with it. So have a great rest of your day, and we will see you later. And once I find the actual video for Countdown, there's the outro. All right, bye everyone.